What is dark matter made of, and what are its properties? Can ordinary matter be converted into dark matter, and is our universe held captive by dark forces? Well, in the year 1933 in Switzerland, Fritz Zwicky observed that galaxies in distant outer space clusters were rotating quite rapidly. Now, the visible matter present in them was not enough to support such fast movement. So, how did these galaxies become stable? Zwicky suggested that there is a form of matter present in these galaxies that is not visible to the naked eye. He named it dunkle Materie, which we now know as dark matter. In today's video, I will share with you the mysteries of this dark matter. Friends, when scientists are asked, or in the end, what dark matter is, their heads start spinning because it is a kind of puzzle that, despite all efforts, is proving quite difficult to solve. In the simplest words, it is the type of matter that exists in every corner of the universe, but cannot be seen with our eyes, and not only our eyes but also cannot be seen with the help of any equipment. According to an article on space.com, dark matter occupies more than 80% of the total matter in the universe, meaning that what we see in this universe is less than 20% of the matter, and a very large part of this universe we cannot see. Until a few years ago, scientists believed that dark matter was composed of black holes and stars that had lost their light, and therefore, we could not see them. However, recent studies have refuted any claims from these theories. So, what is dark matter made of? According to NASA's website, it comprises weakly interacting massive particles, WIMPs, hypothetical particles that behave like neutrons but are more than 100 times heavier than protons. They absorb light and do not emit light, nor do they interact with other particles. In other words, they exist around us, but we cannot see them or detect them with any equipment. However, if they are particles and follow the laws of physics, there is at least a 1 in 100,000 chance that they will collide with protons or neutrons, and we will have concrete evidence of their existence. In pursuit of this, scientists have conducted thousands of experiments using large particle accelerators underground to collide ordinary particles with WIMPs. Still, despite decades of effort, they have come up empty-handed. Now, let's take a look at Xiang Shang's report, which talks about the Chinese PandaX project. This project was conducted in China Jinping Underground Laboratory between 2015 and 2018. The project made significant efforts to understand WIMPs and dark matter, but scientists came up empty-handed. Now, according to them, particles smaller than dark matter WIMPs may exist, and studying such particles with today's technology is not possible. But is it necessary to create droplet effect particles? If we talk about ordinary matter, it is not made up of just one type of particle but several types. For example, if we consider an atom, it may have protons, neutrons, and electrons. So, is it not possible that dark matter is also composed of various types of particles coming together? It could be that dark protons combine with dark electrons to form dark atoms, creating dark matter. Scientists currently have no evidence for this, but if it is true, there must be some fundamental processes among them. According to an article on livescience.com, when there is an exchange of photons between ordinary matter, electromagnetic force is created. Some researchers in Italy are actively engaged in exploring dark matter, and for this purpose, they are colliding beams of electrons and positrons using diamonds. They suggest that if dark photons exist, then electrons and positrons colliding with diamond may give birth to a new type of force-carrying particles. If this experiment is successful, we might discover the fifth force of the universe, leading to the rewriting of all physics books. Additionally, one might wonder if dark matter is composed of particles and has forces. Do its antiparticles also exist? According to some theories related to dark matter particles themselves are their own antiparticles, meaning that particles and antiparticles are the same. This implies that if two particles of dark matter collide, it would make no difference. In the year 2018, a report published by Harvard University revealed interesting properties of dark matter. To understand it better, let's go back to the beginning of the universe, after the Big Bang, when the first stars began emitting UV radiation. At that time, the wavelength of this radiation was 21 centimeters. This occurred approximately 20 million years after the Big Bang, and the entire universe was filled with cold hydrogen. Now, this cold hydrogen started absorbing the UV radiation emitted by the stars. In February 2018, when scientists obtained some signatures of this radiation, their analysis revealed that the cold hydrogen would be even colder than expected. According to Julian Munoz, an astrophysicist from Harvard University's Department of Physics and the leader of this project, particles of dark matter could be behind this, extracting heat from hydrogen with their electrical charge and making it even colder. However, as of now, no confirmation of this theory can be obtained. Friends, many theories have been proposed about the formation of dark matter. However, if I were to tell you that ordinary matter in the universe is decaying to form dark matter, would you believe it? Well, it's quite a strange idea. Let's understand it with an example of ordinary matter. Between every atom present in the universe, there must be a neutron. However, this neutron is powerful only when it is in its own area, meaning the life of a lone neutron with a proton and an electron lasts not more than 14 minutes and 30 seconds. After that, it decays into an electron, a proton, and a neutrino. But some physicists believe that there could be another possibility. In a study conducted in 2018, it was suggested that if only 1% of the decays of all neutrons in the universe contribute to the formation of dark matter, then the formation of dark matter has been possible from the beginning of the universe until today. In simple words, scientists believe that the formation of dark matter could also occur due to the decay of ordinary matter. Christopher Morris, a scientist at the Los Alamos National Laboratory in New Mexico, USA, conducted research with his team on the formation of dark matter due to neutron decay. However, even after all the experiments, they did not find any evidence that definitively supports this theory. Although scientists say that it is not necessary for dark matter to be created only by neutron decay, there could be the involvement of some other particle of ordinary matter. Now, after hearing so many theories and concepts, you might also have the same question in your mind. Are we humans searching for dark matter on the right path? And the biggest question is whether the thing we are looking for really exists or not. Well, there is also a group of scientists who believe that things like dark matter do not actually exist in reality. According to them, the results behind the missing matter in distant galaxies lead us to MOND, which stands for Modified Newtonian Dynamics. Essentially, scientists who adhere to this model argue that nothing like dark matter exists, and the rapid speed of distant galaxies, despite less matter, is concealed within the laws of gravity. However, as of now, we cannot fully understand these laws properly. They suggest that gravity works differently at the level of large objects like galaxies, which traditional laws of gravity cannot explain. As for the theories about dark matter being proposed, the confirmation of the theory of dark matter is still a distant matter. What do you think about it? Whether dark matter is real or not, please share your opinion in the comments below.